right, so today we are going to be graphing an ellipse, writing the equation of an ellipse, and putting an ellipse from general form to standard form. So what is an ellipse? An ellipse is a set of all points such that the sum of the distances from each focal point is equal. As the two focal points get closer together, the ellipse approaches a circle. So if you're looking at the two ellipses below, the horizontal and the vertical ellipse, we have the sum of the distances from each focal point is equal. So if I pick a point on my ellipse, the distance from one focus and the distance to the other focus to that point, that sum is always equal. So F1 plus F2 is always equal to a constant. We'll call it K. So that is what an ellipse is a set of all points where that sum is constant. A little bit of vocab. The equation of an ellipse is such. So very similar to a circle where we have x minus h, that quantity squared, plus y minus k, that quantity squared. But the difference is an ellipse is always equal to 1 versus a circle where it's equal to the radius squared. Another difference too between an ellipse and a circle is an ellipse we're dividing by different numbers. If those two numbers are the same, it is then a circle. That's really the biggest difference between an ellipse and a circle in terms of the equations. If an ellipse, your a squared and your b squared will not be the same. If your a squared and b squared are the same, then it's a circle like we did right before spring break. So a little bit of vocab. The endpoints of the major axis are called the vertices. The length of the major axis is the distance between the vertices. The endpoints of the minor axis are called the covertices, and the length of the minor axis is the distance between your covertices. And your foci are always located on the major axis. So how do you know which one's the major axis and which one's the minor axis? Well, for an ellipse, the longer length is the major axis. So the easiest way to remember that is with your a and your b. If your a squared value is greater than your b squared value, then we'll have a horizontal ellipse, meaning the distance from your center right-left is where your vertices are, meaning the distance between those two vertices is your major axis. Distance up-down then is where your covertices go. This distance here is our a value, and this distance here is our b value. And then in the example where a squared is greater than b squared, our horizontal distance is greater than our vertical distance, so our foci will be on the horizontal axis. And that distance from center to focus is our c value. And we have a little equation to find the c value, and that's very similar to Pythagorean theorem, but instead of adding, we're subtracting. A squared minus b squared equals c squared. If we have a vertical ellipse, that will be when our b squared value is greater than our a squared value. So that means that our vertices now are up-down, and our covertices now are right-left, since b squared is now greater than a squared, which means that our foci will then be up-down, so that distance is c. And our equation to find our foci change a little bit. Since b squared is now greater than a squared, we have b squared minus a squared equals c squared. One more little piece of vocab and then we'll get to graphing. Eccentricity. So the eccentricity is how round the ellipse is. I'm going to zoom in just a little bit more. Is how round the ellipse is. If the eccentricity is 0, then it's a circle. If the eccentricity is greater than 0 but less than 1, it's an ellipse. If the eccentricity is equal to 1, it's a parabola. And if the eccentricity is greater than 1, it's a hyperbola. And we'll learn that in our next section. So on Monday or Tuesday of next week. To find the eccentricity, we take C divided by A, where C is the distance between the center and the focus, like above, and A is the distance of the semi-major axis, meaning half the length of the major axis. So again, that's half the length of the major axis. So notice it could be B instead of A if it's a vertical ellipse. So if it's a vertical ellipse, then it's this distance here, B, that we're dividing C by, but C is always C. All right, so let's do an example. Example number 1, we have x minus 3, that quantity squared, over 36, plus y plus 2, that quantity squared, over 25 equals 1. So we know that this is an ellipse because we are adding. And I know that this is going to be a horizontal ellipse because 36 is bigger than 25 and 36 is under x squared. So first things first, let's find our center. Our center will be at 3, -2, because opposite of what we see. So our center will be at 3, -2. And then the number underneath x minus 3 squared is 36. So that means we're going to go right and left 6. I got 6 because the square root of 36 is 6, because remember that's equal to a squared. So from my center, I'm going to go right 1, 2, 3, 4, 5, 6, and left 1, 2, 3, 4, 5, 6. And that's where my vertices are. So my vertices are at -3, -2, and 9, -2. My co-vertices are going to go up, down 5. I got 5 because the square root of 25 is 5. So from my center, I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. So like you can see, if these two values are the same, it creates a circle. Since these two values are very close to each other, it's going to be a very circular ellipse, which we'll see in a second when we connect those dots. So that means our co-vertices are at 3, -7, and that should be 3, 3, not 3, 5. To find our focus, we're going to use the equation a squared minus b squared equals c squared. So our a squared is 36, our b squared is 25, which means a is 6, b is 5, which is again why we went right, left 6, up, down 5 from our center. And to find our c value, we have 36 minus 25, which is 11, so c is the square root of 11. So from my center, I'm going to go up and down square root of 11, which is just over 3. There-ish. I'm sorry, not up, down, right, left. What am I doing? Erase, erase. Right, left. 1, 2, 3. And the reason why it's right, left is again because 36 is bigger than 25, so our major axis is horizontal, so our vertices, our foci are always along that major axis. So I don't know what square root of 11 is. I can't add 3 and square root of 11 together. They're not like terms. So we just leave it as 3 plus square root of 11, which gave us this coordinate here, 3 plus square root of 11, -2, and then 3 minus square root of 11, comma -2 gives us that other coordinate. So now we connect the dots and get our ellipse. the best that you can. Our major axis is the distance between our two vertices. So that's 12 because we went right 6, left 6, so a total distance of 12. Minor axis is 10 because again from our center we went up 5, down 5. And our eccentricity is c over half the length of the major axis. So that will be a square root of 11 over 6. I want to remind you guys that at any point you can pause this, you can rewind this, and make sure that you're keeping track of questions, because when we have our office hours on Friday, I will be going through any questions that you guys had over the lesson or over the homework. All right, example number 2, a little bit different because this is not in standard form, it's in general form. So we need to complete the square with both x and y to get this into standard form. So is this in standard form? No, we need to put it in standard form. So start by grouping your x's together, x squared negative 12x, and then the 4y squared plus 64y, and then I choose to move my constant over to the other side. Now, when we had an example like this for a circle, we were able to do an easier way of completing the square and just dividing our leading coefficient away. But in this case, since it's an ellipse, our leading coefficients of x squared and y squared will not be the same, so we cannot do that. So instead, what we first do is, since the leading coefficient of y squared is 4, we have to start by factoring that out. So we factor the 4 out, and we're left with y squared plus 16y. Because again, 64 divided by 4 is 16. So now we can complete the square. So starting with x squared minus 12x plus 36, we have b divided by 2, square it. And that's what we add to both sides. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So I add 36 to both sides. And then 16 divided by 2 is 8. 8 squared is 64. But I didn't actually add 64, right? I added 4 times the quantity 64. So I added 256. So when we are balancing this equation, you need to make sure that you're adding 256 to the right side, which again, we got by doing 4 times 64. That factored out 4. So left side, x squared minus 12x plus 36 is a perfect square trinomial. It factors to be x minus 6, that quantity squared. And y squared plus 16y plus 64 factors to be y plus 8, that quantity squared. So we get the quantity x minus 6 squared plus 4 times the quantity y plus 8 squared equals 4. When you add negative 288 plus 36 plus 256, we end up getting 4 on the right side. And we're almost there, but a standard form of an ellipse is equal to 1. So we need to divide everything by 4 to get this into standard form. So that's where we end up getting x minus 6 squared over 4 plus y plus 8 squared over 1, because 4 over 4 is 1, equals 1, because again, 4 over 4 is 1. So now this is in standard form, and now we can identify all of our information. So this one is also a horizontal ellipse because 4 is bigger than 1. So we're going to be moving further right left than we are up down. So our center is going to be at 6, negative 8. So we graph that, graph it real quick. 6, negative 8. And then I will do that. And our vertices are going to move right, left 2, because the square root of 4 is 2. So right 2, left 2. And our co-vertices are going to be at, I moved 3, hang on. And our co-vertices are going to be up 1, down 1, because square root of 1 is 1. So our vertices are at what did I mess up? Ooh, all right, reverse, reverse. I graphed 4, negative 8 instead of 6, -8. So messing up the center messed up that whole thing. So let's redo that. So our center is at 6, -8. And then we went right, left 2. So there's our first vertex at 8, -8, and then left 2, 4, -8, and then up 1, down 1 for our co-vertices. So our co-vertices are at 6, -7, and 6, -9. And then that means the length of our major axis, since from our center we went right, left 2, so that's 4. Minor axis, since we went up, down 1, that's 2. To find our foci, we're going to do c squared equals a squared minus b squared. So 4 minus 1 is 3. So our foci will be right, left, square root 3 from our center. So they will be at 6 plus square root 3, which is about there, comma -8. And 6 minus square root of 3, comma -8, which is about there. So we connect the dots, and there's our ellipse. Last thing is we want our eccentricity. So that again is c divided by the half the length of the major axis. So that will be square root of 3 divided by 2. When you're doing your foci, if they don't come out to be a nice integer value, do your best estimate to graph where that would be. So square root of 3 I know is less than square root of 4, so I know that it's just less than 2, so that's why I moved right and left a little bit over 1. All right, so writing the equation of an ellipse. So find the equation of an ellipse in standard form given the information. We're given the vertices are at 3, 1 and 3, -9, and the co-vertices are at -1, 4 and 7, -4. I am a very visual person. I need to see this graphed in order to be able to kind of conceptualize it all. So that's the first thing that I'm going to do. I'm going to graph my co-vertices and my vertices. I'm going to label them as well so I know which one's which. So my vertices are at 3, 1, 3, -9. My co-vertices are at -1, -4, and 7, -4. So that means that this is a vertical ellipse, which means the number underneath y squared is going to be bigger than the number underneath x squared. So the first thing we need to do is we need to find our center. So our center is going to be in the middle of all of this. So the point that's in between our two vertices and the point that's in between our two co-vertices. So that will be at 3, -4. So our center is at 3, -4, which means I right now know a decent amount of my equation. I know it's going to be x minus 3, that quantity squared, plus y plus 4, that quantity squared, equals 1, because it's always x squared plus y squared equals 1. Now I just need to figure out what number goes underneath x squared and what number goes underneath y squared. So from my center, I went right, left 4. I went from 3, -4, I went right 3 to get to 7, -4, and the left 3 to get to -1, -4. So that means I know I'm going right, left 4. So the number underneath x squared will be 16, because 4 squared is 16. And then from my center, I went up, down 5, because from my center, 3, -4, I went up 5 to get to 3, 1, down 5 to get to 3, -9. So the number underneath y squared is going to be 25, because 5 squared is 25. And there we go. There's our answer. All right, and then our next example, we know that the foci are at 2 plus square root 20, comma -3, 2 minus square root 20, comma -3, and our major axis length is 12. So this tells us that we are going to have a horizontal ellipse because my foci are moving to the right and to the left square root 20. So that means that my major axis is moving to the right and to the left. I also know that my center is at 2, -3, because from my center, I move to get my foci. So I have my template so far, x minus 2 squared plus y plus 3 squared equals 1. And now I just need to figure out the numbers that go underneath 8x squared and y squared. So from my center, since I'm moving right and left a total distance of 12, that means that I know that half of my major axis, or my a value, is going to be 6. So 6 squared gives me 36. Now to find the number underneath y squared, we have to use our formula for our foci. So our c squared equals a squared minus b squared, and remember it's always bigger number minus smaller number. So 20, because square root of 20 squared is 20, equals 36 minus b squared. Subtract the 36, so we have -16 equals -b squared, which means 16 equals b squared, and that goes under y squared. So there we go. There's our answer for example 4. And then our last example is just going from general form to standard form. So again, a bit more practice with completing the square. So you want to start by grouping your x's and your y's together. So we get x squared minus 48x plus 5y squared plus 30y, and then moving your constant over to the other side, so now equals positive 27. So you can't complete the square with a leading coefficient other than 1, so we need to factor the 12 out of the x's and a 5 out of the y's. So we factor the 12 out of the x's, and we get x squared minus 4x, and then 5 out of the y's, which gives us y squared plus 6y. So now we complete the square, and we have 4 divided by 2 is 2. 2 squared is 4, but I didn't actually add 4. I added 12 times 4, so 48. And then 6 divided by 2 is 3. 3 squared is 9, but I didn't actually add 9. I added 5 times 9, so 45. So when you add the numbers to the right side to keep the two sides balanced, we added a 48 and a 45. So we complete the square, and this gives us 12 times the quantity x minus 2 squared, because x squared minus 4x plus 4 factors to be x minus 2 times x minus 2. And y squared plus 6y plus 9 factors to be y plus 3 times y plus 3. So we get 5 times the quantity y plus 3 squared equals 120 when you add up the right side. And then we're almost there, but again, an ellipse is equal to 1. So we divide everything by 120, and we end up getting the quantity x minus 2 squared over 10 plus the quantity y plus 3 squared over 24 equals 1. So I hope this video was informative. Again, go at your own pace, rewind and rewatch and pause whenever necessary, and make sure that you're keeping track of questions. So when we meet on Friday for our digital office hours, you can ask me any questions. All right. Your homework is a worksheet. It's posted on Google Classroom along with this lesson. So go ahead and print out that worksheet and complete that. And again, come with questions for me on Friday. So I hope you're all staying safe, staying sane, and staying distant. And I will talk to you all later. Bye.